All right, guys, here we go. Sorry, making sure it's working. Tried it on a different computer today. So, number one. So this is spring final review, Wednesday, May 15th. So they want you to graph this bad boy. You can try to factor it, but nothing's going to multiply to make 13, but adds to make -6. So we are going to use our x of the vertex system, and we're going to do -b over 2a. Remember, there's an imaginary 1 right there. So that's a, this is b, this is c. So we get -6, -b, over 2 times 1, which is going to give us 6, 3. So x equals 3. Now to find the y of the vertex, I just plug it back in, and I get -3 squared minus 6 times -3 plus 13. Clean this up, 9 plus 18 plus 13. Something doesn't feel right. What doesn't feel right? Because this is not a positive, that's a negative. And we get -9 plus 13 equals 4. So now I've got a point of 3 and 4. And if we look at the graph, which should still be on the screen, yeah, I'm in the way, so it is. We have x is 3, y is 4, and since the graph, they only give you this much, really, there's no way it's going to move down, so all we do is turn it up like that, just like that. Okay, so that's number one. That's how that one flies down. Now, let's look at this one here. The next one is going to be, oops, y equals 2, x plus 1 squared minus 3 equals 0. So then when we're looking at this, we have our h is equal to -1, our k is equal to -3, so I took the opposite of for h and I kept it for k. So I do know right now that if I go over to -1 and down 3, I've got a point right there. So I've got a U-shape somehow, and somebody asked me today, well, how do you solve for the x-intercept? Easy way to do it, 2x plus 1 squared minus 3 equals 0. Then I'm solving equations. So we're going to do add 3 to both sides. So we end up with 2x plus 1 squared equals 3. Divide both sides by 2. We get x plus 1 squared equals 3 over 2. And then we take the square root of both sides, which is going to be x plus 1 equals the square root, plus or minus the square root of 3 over 2. And then you would use your calculator at this point, and you go, okay, -1 plus the square root of 3 over 2. You put that in your calculator, and then we have an or, -1 minus the square root of 3 over 2. So that's 1.5. So that's 1.5. 1.5. So that's 1.2. So that's 1.2. So we got a 0.2 in there somewhere. I'm totally guessing right now. And if that's 1.2 and 1 that way, that's going to be -3.2. So we're over here. And we got that one. So I estimated them because I know how to do that. You can use your calculator. Works fine for me. Alrighty then. So let's tackle this bad boy here. Let's look at the next one. Alright, guys. So, solve the equation. Number 3. Number 3 is r squared equals -9r minus 14. If we're solving it, I'm going to ditch red and go back to blue. If we're solving it, we've got to get everything on the same side. So I'm going to go r squared. I'm going to add 9r over here. Oops. And I'm going to add 14 over here. That means there's nothing left on that side, so I got a 0. So now I've got a couple of different ways I can solve this. You guys know we've done them multiple different ways. R squared goes here, 14 there. We've got 1 and 14 here. And so the idea is this. What multiplies to make 14? Let's say 2 and 7. 2 times 7 is 14. We put our R, not our X. We put our R there and our R there. So now we can factor it out. That's an R. I can divide a 2 out of that one. I can divide an R out of this one. I can divide a 7 out of that one. And this breaks down into R plus 7 and R plus 2, and that equals 0. Same thing here. What multiplies together to make 14, but adds to make 9? It's 2 and 7. These are the same kind of idea. And so then we end up with zero product property and the zero product property again. And I get those two for my answers. I don't care which way you factor. You can do factor by grouping also. It doesn't matter to me. So, number 4. Number 4. Number 4. I'm going to set it up for you, and you can do the work in the calculator. N squared minus 3n minus 26 equals 0. So, they want you to solve this one. So you can factor it if you want to. I'm not going to factor it because I wouldn't want to. So remember, this is A, this is B, and this is C. So we know that A is equal to 5, B is equal to negative 3, and C is equal to negative 26. This is what you want to write on your note card next week. X-intercept is equal to negative B plus or minus B squared minus 4AC all over 2A. That is what you use to plug these bad boys into it. So we get negative B plus or minus B squared minus 4 times A times C all over 2 times A. Okay, now we'll extend this because that's proper. What I want you guys to watch out for is this. These two little negatives right here. You got to make sure that your negative is good inside of here. And don't forget, when you put it in the calculator, you have to put a negative inside the parentheses, or it gives you the wrong answer. So that's how you would set it up in the calculator. Remember, there's two answers. Negative. We got the plus this piece, and we have the minus this square root. So make sure you plug that into the calculator correctly. That's how they get the answer for that one. So we are already on to number 5. We are steamrolling this bad boy here. All right, so here we go. All right, we got our square root ones. These are a little different. No equals. No. Man, I wrote that completely wrong. Let's just try a different color. 3 equals negative 4 plus r over 4. Yes? Yes. Okay, so we got a square root. So this means I'm going to square both sides. That means I'm going to square both sides. But here's my idea for you. Make sure you make it as simple as possible before you do that. So I'm going to add 4 to both sides. That's where that comes from. So those are gone, and I get this, r minus 4. R divided by 4, sorry. Now I've got a square root all by itself. We're golden. We square this beast of an equation, and then 7 squared is 49. The square of a square root is the root itself. So now I've got this piece right here. We're looking at a simple equation. How do I get r by itself? Well, I'm dividing, so to undo dividing, I've got to multiply. Multiplication is the game. The answer is never the same. I don't know, that was a lame rhyme, so let's go with that. There we go, r equals 196. Okay, so remember, when you have extra stuff, move it to one side. So we're not dealing with a bunch of extra pieces that we don't like anymore. All right, so look at that. I'm already on to number 6. Man, and so somebody brought it to my attention that I wrote down the problem wrong yesterday. Well, that happens a lot. So make sure that that's useless here. I don't like that one anymore. It's an ugly color now. All right, so we're on to number 6. 5 negative 3n minus 3 equals 125. Okay, somebody said, can I do the natural log for this one? Yes, you may. It will work out. If you're comfortable with that, go for it. If not, I'm going to show you how to create a one-to-one. Remember, for bases, you have two choices. You can do the one-to-one, which means I got to make it a base that's the same as 5, or you can use natural log. I don't care. Either one. So I'm going to do, just so you guys can see one-to-one some more, I'm going to change this into a base of 5. This means 5 times 5 times 5. That will give me 125, which lets me go full circle and make 5 to the 3rd power. Voila! One-to-one. Out of there, negative 3n minus 3 equals 3. Lots of 3's. Crazy. So then we solve for n. I'm going to add 3 to this side. Gives me a 6. Then I've got negative 3n. At that point, I can divide by both. Negative 3, and then I've got n equals negative 2. There is my answer. I hope this thing's still recording. Yes. We are still a champion. All right, so halfway there. I'm moving faster than yesterday. You guys are getting good at this, so I can go faster. All right, so then we got negative 4 times 8 p raised to the power of p plus 1 equals negative 10. So they want us to solve this bad boy. This is number 7. Number 7. All right, so remember, we want to get this stuff all by itself. So how do I do that? Well, this is multiplication. If it's multiplication, got to divide. So 8 to the power of p plus 1 equals negative 10, negative 4, divided by negative 4. Let's clean this up. This actually becomes 2.5. So that way we're dealing with that. So now I've got this. I've got 8 p plus 1 equals 2.5. These can't become one-to-one, so I can natural log both sides. And natural log that bad boy. So what happens is this drops down, becomes a multiplier, and I have this right here. So how do I get this by itself? I got to divide the natural log of 8 out of the way. You can put that in your calculator. And so my answer, you can do a calculator for the actual piece, is P is equal to this beast, natural log of 2.5 over natural log of 8, minus 1, because I got to subtract the 1 over. There's my number 7. All right. So we will do 8 and 9 really quick. 8 and 9. Remember, we have for this one, we have x minus h squared plus y minus k squared equals r squared. That's the piece that you really, really want. And we end up with a center of negative 10 and 2. So now I've got opposite in here. I've got plus 10 squared. K is going to be the opposite, which is going to be y minus 2 squared. And R, they give us an R of 5 squared. So 5 squared gives me 25. That is my equation right there. If we flip it over, they give us x plus 1/2 squared plus y minus 7 halves squared equals 9. At this point, I'm still working with this equation up here on top. Taking the opposite, negative 1/2, opposite, 7 halves. R squared is equal to 9. That means R is equal to 3 because I got to take the square root of both sides. So we've got all this stuff going on all in one equation. 1/2 is right here, about 0.5, and 7 over 2 is 3.5, so we'll go up to 3.5. That's our center. Over 1/2, up 3.5. And I need to go out 3, so I'm going to go 1, 2, 3. So I'll make this negative 1/2 over here. Go 1, 2, 3. 1, 2, 3. What am I doing? 1, 2, 3. 1, 2, 3. 1, 2, 3 from the radius. And then draw my sort of circle. There we go. That's the answer for number 9. Number 9999. Okay. So here we go again. Alrighty, everyone. Here we go. So let's look at our trig stuff here. So the next 3 are trig. The next 4 are trig. So trig information. The trig information that we have. I'm going to write the trig information here. I'm going to do the problems over there. Hopefully that works. Yep, that'll work. Okay, so we have SOHCAHTOA. Let's write this out a little differently. So we're going to go sine is always opposite. Oops. Opposite over hypotenuse. Cosine is always adjacent over hypotenuse. And then tangent is always opposite over adjacent. And then we have what are inverse functions. Inverse functions, and these are in the calculator, so we got to do the calculator for these. And all that is the inverse of sine is sine to the negative 1. The inverse of cosine is considered what's considered arc cosine or sine cosine to the negative 1 on your calculator. And then tangent is our arc tangent, which is our inverse tangent. So this is a button on the calculator, and this is a button on the calculator. One undoes the other. Not unlike, how do I get rid of a square? I take the square root. The square root undoes the square. The square undoes the root, which means the sine undoes the inverse, and then inverse sine undoes the sine function. So that's why we're here where we're at. So let's look at number 10. Number 10, 10, 10. Number 10 gives us the sine of theta. Don't forget theta is just a variable. It's like x. You can put x there if you'd like. And then I'm going to draw the triangle that they give us. We got our 90. Across from the 90 is the 20. Theta is right here. 12 is here. Let's label our sides. Next, across from here is the whoops. They're drying out. I need to put the lids on. And then next to it is adjacent, and across is the opposite. So I'm looking at, oh, well, wait a sec. They give me adjacent and hypotenuse, but I need the sine, which is opposite over hypotenuse. So I'm going to have to redo this, and I got to use a squared plus b squared equals c squared. Now, this is always, h is always c, so we got 20 squared. A, it doesn't matter, you can put a over here, so this is 12 squared. So I'm looking for my opposite squared. So this is 144 plus o squared. If you use b, that's fine. I can put b there, it doesn't matter. Over 400. B squared equals a number. Minus 100 is 300. Minus 40. 300 minus 40 is 260. Minus 4 is 256. Oh, that works out beautifully. And we get b is equal to 16. Check my math. I'm pretty sure I'm right. All right, so we get opposite equals 16. What we say we needed, sine of theta is equal to opposite over hypotenuse, which is equal to 16 over 20. 4 goes into that 4 times. 4 goes into 20 5 times. My answer is 4 over 5. We are just rolling. You guys are good. You're going fast. All right, so let's tackle this bad boy here. Number 11. Still using this information over here. Number 11. Let's see here. They give us another triangle. Looks like this, something like that. I don't know. I'm not very good at triangles. 55, 10.9, and x. So they give us this one. Let's label things. Since they give us this one, that means this one here is adjacent. Can't spell very well. Adjacent. And this one, oh no, it's not. I made the biggest mistake ever. Across from the 90 is always the hypotenuse. This one is the adjacent, and across is the opposite. So what do they give us? They give us opposite and hypotenuse. Opposite and hypotenuse have to do with sine. So the sine of something is equal to opposite side over the hypotenuse side. Well, we have all the information we need, which means the sine of 55 is equal to opposite 10.9 over x. Now I just got to solve for x. That's what I'm looking for. So sine of 55, put that in your calculator. You're going to get a decimal. Oh, look at that. Handy dandy. Somebody left your calculator out. Put these things away, people. Come on. All right. So we got the sine of 55. 0.891. So 0.891. Let's make sure I read that right. Nope. 819. I knew it. 819 equals 10.9 over x. So I got to get rid of the x, so I'm going to times that by x, and I'm going to times this side by x. So now I get x multiplied to 819 equals 10.9. How do I get rid of that? Divide that by 0.819. Divide this by 0.819, and then x will equal whatever that calculator gives you right there. Let's just do it, just because we're cool like that. So 10.9 divided by 0.819, touchdown of 13.3. 13.3, there we go. That's number 11, people, just using these sine functions here. Okay, so let's tackle the next one, which is number 12. Number 12, they draw a triangle I can draw, which is a really weird one because I'm not good at drawing triangles. So they got something that looks like that. They give you this tiny little 3.8. C is this angle, A is that angle, and B is this angle. We call that the 90, and we got 13. So, and they say, oh, theta's right here. Let's draw theta in here. It's real skinny right there. Theta's right there. So, let's label this bad boy out. This is a 13. So, if I look across from the 90, I'm always looking to find the hypotenuse. There's a lot of people moving. Is the bell going to ring soon? 2:0, whatever. I don't know. Hopefully not. We'll see what happens. So, almost done with this, and then I can upload it for you guys. So I got my hypotenuse. This is my theta, or my reference angle, so that means this is my adjacent, and this is my opposite. So what do they give us? They don't give us the adjacent, don't care, so we don't care. And then we don't care about that one because they don't give us the adjacent, but they give us the opposite, so I'm either tangent or sine. But they give us the hypotenuse, so I'm up here with sine. So the sine of something is equal to opposite over hypotenuse, which means the sine of theta, because they give us theta, is equal to the opposite over 13. But sine's in the way. I need theta. I need that one all by itself. So how do I get rid of theta, sine? And get theta by itself, I use its inverse function like I would take the square root of both sides. So the inverse function is going to be the sine of the arc sine, or the inverse sine of theta of both sides. So I've got to do the inverse sine of this one also. Okay, so then that gives me this. So these cancel, and I'm left with theta. So theta is what I'm looking for, and then I'm going to do the arc sine, or the inverse sine, of 3.8 over 13. And you put it in the calculator just like that. This is the second function. You got to hit the second button on your calculator. It's a second function, so I'm going to hit second, sine, which gives me, I don't know if you can see this, but it gives you the sine to the negative 1. I don't know. And then you're going to put your fraction in there, 3.8. And somebody asked me today, well, what's fraction? Well, it's division. So we just do 3.8 divided by 13. 13, close the parentheses, hit enter, and this angle is about 16.99 degrees, or approximately 17 degrees. That's number 12. So the last and final piece of trigonometry we need right now is this. We have a negative 315 degrees. So this is 13. So when I'm given this, I go, oh, I don't know what I'm supposed to do. Then I read the directions. The directions are always helpful. Convert each degree measure to radians, degree to radians, degrees to radians, degrees to radians. I want radians on top, which means I'm multiplying it by pi over 180. So my answer has to have pi in it. They give me degrees, I need pi in it. If I have pi in it, I'm going to get rid of degrees, which everybody likes pi. I mean, if you don't like pi, we'll have to talk later. It could affect your grade. Okay, so here we go. And then we multiply these straight across. Remember, there's an imaginary 1. So I get negative 315 over 180 pi. That's my answer. You got to do some crazy figuring out here. So negative 7.4 pi. That's my answer. I'm sticking to it. Probably asking me how the heck I did that. So I did it this way. We have 3 triangles based on the unit circle. We have the 30-degree triangle, the 45-degree triangle, the 60-degree triangle, and the 90-degree triangle. Those of you going to Math 3, this is where we're headed. I know 30 and 60 do not go into 315, so 45 has to go in there. So 45 goes into 184 times, and trust me on this, if I divide 315 divided by 45, it gives me 7. The bell just rang. You're going to your transition rally, and I did this just in time. Have a good time, people.